Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And we are from Group 7. And for Physical and Organic Chemistry, TST0925, we will present about question number 7, which is question that related to haloalkane. And our group members is me, myself, Haikal Azhan bin Hamdan, 9211214. We have Muhammad Ikhwanuddin bin Rizwan Amin, 9211226, and we have Muhammad Alif bin Ismail, 9211220. Okay, task 1. Synthesis and reactions of organic compound. Compound B, CH3, CH2, 2CN, can be formed from a haloalkane A, C3H7Br. Suggest the structure of haloalkane A and give its IUPAC name. Set the classification of haloalkane A and give the reagent and condition necessary to form B from A. And we have a structure here which is C3H7Br. And the IUPAC name from this structure is 1-bromopentane because it have a single bond and Br here, so we will name it as 1-bromopentane. And the classification for this structure is primary halide. Primarily halide. Okay, so the reagent and condition necessary to form B from A is reagent we need KCN and ethanol, which KCN is potassium cyanide and OH is ethanol. And we will need a presence of alcohol, acid and heat. And we will undergo the process called reflux. Next. Next, state the type of mechanism for the reaction occurs and show the reaction mechanism. Okay, so the type of mechanism for this reaction is second order nucleophilic substitution reaction, which is known as SN2 mechanism. And during this reaction, cyanide ion will attack the carbon from backside, expelling the bromide to leave the group. The major product is 1-cyanopropane and the side product which is bromide ion. During this reaction, we will having two hydrogen atoms that attach to carbon and CH3, CH2 that also attach to the carbon. And also we will have two temporary bonds between cyanide ion and carbon and also between bromine and carbon. And the transition states bear negative charges. From 1-bromopropane to the transition state, it will have a slow reaction since it needs to break the bond. And from transition state to 1-cyanopropane, we will have a fast reaction because it is making a new bond. Thank you. I will pass to the next person.
Bismillahirrahmanirrahim. So now I will continue with another question. Compound B can undergo reduction and hydrolysis to form amine and carboxylic acid, respectively. Draw and name the amine produced when compound B undergoes reductions with H2, PT, and heat. Next, draw and name the carboxylic acid produced when compound B undergoes hydrolysis with H2O and H+. So, before this, we know that compound B is 1-cyanopropane. So, 1-cyanopropane can produce two products through two reactions, which is a reduction and hydrolysis. First reaction, compound B. Compound B, which is 1-cyanopropane, undergo reduction to form amine. Our reactant is compound B. As we know, compound B is 1-cyanopropane. 1-cyanopropane will be heat and using reagent H2, gas hydrogen, and PT, which is platinum, will be produced 1-butanamine. For this reaction, Cn from 1-cyanopropane will change with CH2 and H2 to become 1-butanamine. So, this reaction we call as reduction, which is our reactant will adding H, hydrogen. For second reaction is hydrolysis reaction. Compound B or 1-cyanopropane will undergo hydrolysis to form carboxylic acids. So we know that our reactant is 1-cyanopropane will be produced butanoic acid using reagent H+ and water H2O. For this reaction, Cn will change COOH to become butanoic acid. Therefore, we can see that For these two reactions, number of carbon will increase by 1. Alright, now I will continue with next question. Another haloalkane C is the isomer of A. Draw the structure of C. Show how C can be used to synthesize 2-methyl-3-hexanol and benzene 4-dicarboxylic acid respectively. First of all, we know that isomer A is 1-bromopropane and haloalkane C is 2-bromopropane. First, we will using preparation of Grignard reagents, which is 2-bromopropane will react with magnesium and dry ether will produce isopropyl magnesium bromide. After that, isopropyl magnesium bromide will react with butanol to undergo hydrolysis, which is we will using H2O and H plus to produce 2-methyl-3-hexanol. 3-hexanol. So that's synthesis 2-methyl-3-hexanol.
So my name is Muhammad Nikonuddin bin Muhammad Rizwan Amin. My matric number is 9211226. So I would like to continue about this slide is synthesis of benzene 1,4-dicarboxylic acid. So benzene will be added by 2-bromopropane and aluminum as catalyst will form isopropyl benzene NHBr. So CH3Cl and AlCl3 as collision incoming group CH3+. Since isopropyl is one of EDG and it is autopara director, it will form p-methyl isopropyl and O-methyl isopropyl. So with KMnO4 and H plus and heat, it will form benzene 1,4-dicarboxylic acid. So I would like to continue with INAC component assessment. Functional group present is haloalkane. Chosen plant is boron algae and phyllophyta. Related Quran verse is Surah Taha 20:53. A'udzu billahi minasyaitonir rajim. Allazi ja'ala lakumul arda mahdan wa salaka lakum fiha subulan wa anzala minas samaa'i ma'an fa akhrajna bihi azwajan min nabatin shatta. Sadaqallahul Azim. The meaning is he is the one who has laid out the earth for all of you and set it in pathway for you and sent down rain from the sky, causing various types of plants to grow. The Arabic word zawf means one of a pair and its plural is azwaf. And a zawf is that which in the company of another forms a pair. Therefore, azwaf also include in alga as a asexual plant which has been created by Allah and contain many benefits to the human. One of the components in brown algae or cap is iodobutane, occurs naturally in the algae plant, where it is supposedly generated as secondary product of VBRPO. Action on anols, iodobutane contains the halogen compound, which is in the haloalkane series. The structure is shown below. Composition of boron algae is 50 gram carbon, 10 gram nitrogen, 2 gram phosphorus, 51.9 gram carbohydrates, 14.8 gram proteins, 1.8 gram lipids, and 31.5 gram ash. Benefit of brown algae: it is a widely used food and found off the coast of Japan, Korea, and China. Besides its tasty texture in medicine, brown algae are used for a variety of conditions including cancer, fibromyalgia, arthritis, stress, weight loss, heart disease, and other many conditions. Other than that, it is also used in textile and gelling agent, in the pharmaceutical industry, and in making smooth ice creams. So the structure of iodobutane. So this is the chemical reaction, and we use elimination reaction from the TSF rule. So this is our reference. So thank you.